Okie dokie. Number 22. What are the intermolecular forces present between molecules of HCl but not H2? So H2, they're not going to have, the only thing H2 is going to have is London dispersion. Okay. Of HCl, we're looking at HCl, not H2. So the only thing H2 is going to have, like I said, is London dispersion. HCl, however, is going to have dipole-dipole. It's not going to have hydrogen bonding. Hydrogen bonding is only when HOH or HF is present. Okay, because they have to be really, those have to be really strong molecules or really strong elements for that hydrogen bonding to form. Okay, so the only thing, but there is still going to be, there's going to be this Cl, I think. Did we call Cl one of the strong ones? Yeah, we did. So Cl is going to still have a dipole-dipole interaction, okay, with hydrogen. No ionic bonds. Why? Because there's no metals. Okay, London dispersion forces will exist in H2, but dipole-dipole interactions will not exist in H2. Why? Because they're evenly matched. Okay. Water molecules are attracted to each other with this type of intermolecular force, hydrogen bonding. Okay. Hydrogen bonding. So you get this partial negative here. Oops. Oh, I forgot how to draw my lowercase delta all of a sudden. That's terrible. There we go. You get this partial interaction there, and you get a partial positive over here. Okay, and this causes this interaction with another water molecule causes these hydrogen bonds. All right, which of the following is expected to have the highest melting point? Highest melting point is going to be an ionic solid if you can find one, but if not, let me see. Hold on 1 second. Okay, if you can't find one, then you're going to look for one that's got a strong interaction with another molecule of the same type. Okay, that's going to be NH3. You've got a strong weak interaction. Okay, so you're going to have these intermolecular forces that are going to be highly attracted to each other. Okay, similar to hydrogen bonds. All right, similar, maybe even weak hydrogen bonds, you could say. I will probably make this. This is a difficult question. I will probably clarify. Clarify this one. Okay, so I would probably throw in a salt or something like that in there just to make it, because you've got four covalent compounds here, so it's really tough to sort of go down through the list and figure out which one's which. But I will probably clarify by adding a salt in there. Okay, so just FYI. Number 25. What is the bonding capacity of oxygen, and how many bonds can oxygen form? Okay, that's the same thing. So how many bonds can oxygen form? Well, let's draw our what do you call it? Our Lewis dot diagrams. So right here, there's a free space and a free space right there. So it's going to be two empty seats. Okay, so your answer is going to be 2. Next. We skip on over to number 34. Which set of coefficients balances the equation for the complete combustion of ethane C2H6? Hey, you know what I'm going to do? I'll go ahead and do this on a separate sheet of paper. No, I think yes, maybe I can do it here. I'll do it here. C, H, and O. On the left side, we've got 2, 6, and 2. And on the right side, we've got 1, 3, and 2. Okay, so if we start with our carbons, we put a 2 right there. Now we've got 2 carbons, we've got 4 oxygens plus 1 is 5. And if we put a 3 right here, we've now got 6 hydrogens, and we've got 4 plus 3 is 7. Okay, we've got a 7 right there. So what do we need to do over here? To get a 7, we need to put a 3.5. But we can't leave it as a 3.5. We've got to multiply the whole thing to get rid of that 3.5 times 2. So if we do that, we get 2, 7, 4, and 6. That's going to be letter D. Again, I had to get rid of this 3.5 here. The way that I do that is I multiply the whole equation by 2. Okay? So that gives me 2, 7, 4, and 6. Letter D. When the equation for the combustion of propene C3H6 is balanced with the lowest whole number coefficients, what's the coefficient for oxygen O2? So what you need to do in order to answer this is you need to write out your combustion reaction. So you write out C3H6 plus O2 yields combustion reaction CO2 plus H2O. Then do the same thing I just did up here. C, H, and O. Okay, so we've got 3 C's, 6 H's, 2 O's, and over here 1 C, 2 H's, and 3 O's. Alright, let's do it. Same thing. Let's put a 3 here. That gives us 3 of those, and now we have 6, 7 oxygens. And let's go ahead and do our hydrogens next. We'll put a 3 here. So now we've got 6. And now let's count up our oxygens again. We've got 6 plus 3 is 9. Is that right? 6 plus 3 is 9. Okay, so same trick again. We're going to have to put a, well, half of 9 is 4.5. Okay, and then multiply the whole thing times 2. Multiply this entire thing out times 2. So you get 2, 9, 6, and 6. It says, what's the coefficient of oxygen O2? Well, it's going to be 9. Okay, it's going to be 9. Tricky one. When alcohol reacts with carboxylic acid, which of the following is formed? You know what? Hold on one second. Yeah, cross that off. Cross that off. Okay, we're going to skip that. Which of the following substances is considered a strong electrolyte? Dissociates completely. Completely. Conducts electricity. And is a strong acid. Or a salt. Okay. So sugar, no. H2O, no. HF and KBr. Oh, there's a salt right there. This is a salt. Here's an acid, HF. Is it a strong acid? Well, look over here. No, it's not. Okay, so we can cross that off. Look at this list now. I memorized that. You should too. There goes my lights. Notice the way I answered that was by knowing what a strong electrolyte is. These are the characteristics of them. You have your strong acids right here. All these strong acids are strong electrolytes. If it's not a strong acid, then it's a weak acid. Weak acids are weak electrolytes. Okay? Alright, let's go and do the next thing. Which of the following compounds is expected to be soluble in water? So what's soluble in water? Well, you've got your solubility table right here, don't you? I was going to say ionic compounds. Let's see. Calcium, iron, lead, and strontium, all ionic compounds. So we got to go through each one and see. Calcium sulfate. Calcium sulfate solid. No, cross it off. Iron sulfide. And that's going to be ferrous sulfide. Iron 2. You know what I would do? Well, yeah, that's going to be iron 2. Ferrous. Okay, let's just go ahead and keep going. Ferrous sulfide. I was going to say I might change this. I may change that to iron 2, Fe2S. Okay. Let's look. Well, in this case it wouldn't matter, would it? Because either iron, ferrous, or ferric, both of them with sulfide are solid. So no, you can cross that off. Lead chloride. Lead chloride. You can cross that one off. So the only thing left is strontium bromide. Strontium over here, and bromide. Oops, right there. Where'd you go? Strontium bromide. There it is. Strontium bromide aqueous. Okay, so it's going to be letter D. Which of the following represents the dissociation of calcium iodide in solution? So you get the following. You get a calcium 2 plus and I2. Oh wait, maybe it's insoluble. Let's double check. Calcium. Iodide is aqueous. Okay, so you get a calcium 2 plus plus 2I minus. There it is, right there. Okay, calcium 2 plus plus 2I minus. Remember, that dissociates. Dissociates, breaks apart into ions. Breaks apart into ions. Okay, the reason that's not correct, that's an ion, but this is not an ion. Okay, that is not an ion, and that's not an ion. Remember, it's got to break apart into ions. So there you go, calcium 2 plus and 2I minus. All right, that's your answer. Why not just I minus? Well, because there's two of them there. Okay, it's going to break apart completely into its ions. Going way over time. Okay, I'm going to stop this video.